Hey, algebra scholars. In this video, we're going to do some algebra. More specifically, we're going to start with some review on exponents, and then we'll get into polynomials. I'm going to try to keep the video about 10 minutes, so we'll get as far as we get, and we'll pause it and make another. Our aim here is to give you something to use to help prep you for the final exam, 2025, Intermediate Algebra, Quarter 4, Semester 2. Kicking it off with a question that tests our understanding of what negative exponents do. And remember, negative exponents flip things, so that's the language that many of us teachers in the business use. 9 to the power of negative 2 is equivalent to 1 over 9 to the power of positive 2. Once you flip that exponent to the other side of the fraction, the exponent can be turned positive. Remember, 9 to the power of 2 just means 9 times 9. So 2 nines. 9 times 9 is 81, so C is the final answer. A fast question if you know what you're doing. So here we have to pay attention to the things that are negative first. We need to flip those negative exponents. So that a to the second is going to flip to the bottom. Now it's positive. The c to the negative third will flip up to the top. And the b to the fourth stays put because that's a positive 4. So we're not going to move that. So I'm looking for the correct answer, D. Looks to be right. So negative exponents flip. We didn't talk about this in class, so don't worry about this in 2025, but 1, 2, 3, 4, and then 5. So when I'm not even going to muddy the waters here. You'll talk about that in science next year. What is the value of... That's another scientific notation question. I mean, repeated multiplications of 10 move the decimal place one time. So if you move the decimal to the left, that's in a negative direction. If you move the decimal to the right, that would be a 10 to the positive power. So again, it's scientific notation. It's something you'll talk about later. What expression below is not simplified? In this unit, we talked about simplified answers not having negative exponents in them. So H is not fully simplified because of that negative 2. G is not fully simplified. J has a negative value, but we don't like to keep negative numbers in the denominator. We would prefer that that negative was either out front or up top. F is the best answer because that fraction cannot be simplified any further and there's no negative exponents. All right, one more time. This y is going to flip to the bottom. So we'll get x to the third over y to the fourth and then x to the second. And then on the top, we have two x terms, x to the third and x to the second. We want to add those exponents together because x to the third means 3 x's and x to the second means 2 x's. So how many x's do we have? We have 5 of them. And the faster way to think about that is just to simply take 3 plus 2 and get 5. So A. Good. So when we raise powers to powers is a way this is often described. We need to multiply the exponents together. So when you see parentheses like that and there's an exponent on the outside, multiply it into the other exponents. So we have 2 times 3, which is 6, and 4 times 3, which is 12. So F, x to the 6th, y to the 12th. All right. Remember, negative exponents flip things, so when we raise a fraction to a negative power, we can just flip that fraction upside down and then make that power a positive. Once everything's flipped, the exponent turns positive. Now we still need to cube the top and cube the bottom. 3 cubed, 3 times 3 times 3 is 27, and 2 cubed, 2 times 2 times 2 is 8. You're allowed to use a calculator on this, so shouldn't be too bad. Now you could have arrived at this answer if you distributed the power in first and then flipped second. As long as you get D. You know you're doing it right. All right, and last, fractional exponents should be broken up. Okay, we want to break this up into 81 to the power of 1/4 cubed. So notice I took the 3 in the numerator and treated it like its own cubing, power of 3. And the 4 in the denominator as just a 1/4. So I separated that 3 out from it. But what this allows me to do then is address what the 4th root of 81 is. So some students can just look at 81 to the power 1/4 and they know what the question that's asking us to solve. Others work better with the root instead. Remember, fractional exponents are roots, so this is the same thing. Whatever we get, we're going to cube in the end. So the question we have to answer is, what is the 4th root of 81? And that's just asking us what x times x times x times x is. What number times itself 4 times gets you to 81? And the answer is 3. Now again, you're allowed to use a calculator on this. So, if I'm being honest with you, you could just do 81 to the power of 1/4. I'll put parentheses around it. Some of your calculators force you to do that. For this question, honestly, nothing's stopping you from typing that entire original question into the calculator too. I'm going to do it in separate steps though. So I've got 3. Now I'm going to raise 3 to the power of 3 because I remembered that was the last step. I'll switch screens again to show you that, but I just want to catch the answer so I don't need to come back. 27. Okay, so just to remind you, the green highlighted part was 3, but we still needed to cube that. So 3 times 3 times 3 is 27. So hopefully that rings a bell from back in the exponent unit. All right, a vocab question. The word degree refers to the exponent of the highest value 3. So this is a 3rd degree polynomial. Standard form. Standard form would be the form in which the polynomial is written in descending order of power. So we want the highest power, the highest exponent to come first. So I think the lettering got goofed up on this. So let's just be clear on that. Okay. So here the issue is we have a power of 2 on this first term. This is called a term. But a power of 3, which is a bigger power, on the second term. So this is not standard form. Okay, letter B is actually really close. It's just completely backwards. They ended with the highest power, and then we have descending order as we move to the left. That is completely backwards. We're going to want the answer that is opposite of that, and it looks like D. Good. So adding polynomials requires us to simply just combine like terms. All right, adding polynomials combine like terms. So we have 4x cubed plus 8x cubed. I just located the cubes. That's going to be 12x cubed. Well, that doesn't really help me too much. They're all 12x cubed. But I'm always checking. Okay, and then we have, let's see, 2x minus 5x. 2 minus 5 is negative 3. So, good. Looks like I have an answer. It's the only answer, or the only option with negative 3x. There's a plus 4 at the end here. So that does work with that answer. So subtraction, we got to be careful here. I would honestly rewrite this as an addition problem. We have 9x to the fourth plus x squared. And when I say rewrite that as an addition problem, I guess what I really mean is distribute that negative sign in. Because we're subtracting 6x to the fourth. Okay, well, nobody really messes that up. But then we're also subtracting negative 3x squared. And when you subtract a negative, that turns into a positive. So instead of having to think through that, we just say, hey, you just distribute that negative sign in and switch the sign on each of those three terms. So that negative 8 would become a plus 8. But that's because we're subtracting the negative 8. Subtracting a negative is like adding. So then we add like terms and we are done. 9x to the fourth minus 6x to the fourth is 3x to the fourth. It doesn't really help us out when you look at your answers. And then we have 2x squared plus 3x squared. That's 4x squared. Okay, can get rid of those two. And then we've got plus 8. So H it is. Nice. All right. Well, that was a good page. That was good. Let's see here. Okay, we'll see how far we get. Multiplication. Good. So we're jumping around a little bit. Remember, when we multiply numbers with exponents together, we want to add the exponents. So that x to the first is the part of 2xy that I'm focused in on because we're going to multiply that by x cubed. So the 1x times the x cubed, so the x to the first, x cubed, that's going to give us x to the fourth. So when we're multiplying numbers, we add the exponents. So we get x to the fourth. So I'm going to cross off the x to the thirds. All right, we'll distribute one more time. With that second distribution, we've got 2 times negative 3. That's going to be negative 6. So I know right off the bat what my final answer needs to be. I don't really need to finish that multiplication out. It's negative, not positive. Good. FOIL. So remember, when you multiply two binomials together, you got to multiply the firsts, the outsides, the insides, and the lasts. So when you go down that train, first, outside, inside, last, you're going to get some like terms in the middle. You're going to add them all together, and you're going to get your answer. A lot of us math teachers this year use the box method, which is just the array method for multiplication, to organize the multiplication of these two binomials. So you write them on the top and the left side, and you just go ahead and multiply each left and upper part of the, from the box that you're in together and get the product. So x times x is x squared, 4 times x is 4x, negative 3 times x, and negative 12 right there. Then we just need to combine like terms. 4 plus negative 3 is just 1x. So all together, we should get that, which is letter C. Awesome. The length of a rectangle is 5 less than the width. Okay. So the length of the rectangle is 5 less than the width. So if the width is x, the length is 5 less than x. If you read the sentence a couple times, that should be the conclusion you draw. Which polynomial describes the area of the rectangle? Well, to find area, we do length times width. So I want to do length, and then I'll use parentheses because we have a binomial here, length times width. And when we multiply a monomial times a binomial, we need to distribute, of course. X times x is x squared. X times negative 5 is negative 5x. Instead of using x, it looks like they use w's, which actually makes sense because it's width. Either way, I'm going to pick the answer that's got the same setup as mine. Looks good. Hey, all right, this is a easily missed question. A lot of students want to distribute that square in there, but remember, squaring means we're multiplying something by itself. So I'm going to go back to the boxes here. So we're multiplying x minus 3 by x minus 3, and that's going to force us to use the FOIL method, first outside, inside last, or the box here. So we get x squared minus 3x minus 3x plus 9. Negative times negative is a positive. Negative 3x plus negative 3x is negative 6x. So it looks like D is the answer I am looking for. Not a hard question, often missed when students rush. All right. GCF stands for greatest common factor. There were a couple ways that we went about this in class, but I think a lot of us teachers this year, we did prime factorization. That's great. I think a lot of us, though, kind of just landed on saying, all right, let's look at our coefficients, 10 and 15. What's the biggest number that goes into 10 and 15 nicely? And you think, well, 5. 5 is the biggest number that goes into 10 and 15 nicely. And with 5, if you want to do this using prime factorizations, we can split 10 up into 2 times 5, and we can split 15 up into 3 times 5. So what do they have in common in terms of our prime factorizations? Well, they have a 5 in common. So that's another way of determining the GCF. Anyway, 5 should be a part of our greatest common factors. We can cross H and J off. So then the question is there a letter that both of these terms have in common with each other? Is there a letter that both terms have and they have at least one of or more of? And it turns out that both terms have at least one x. They have one x. The first term has 2 of them with the x squared, but the second term only has 1. So we got to default to the smallest amount. So G it is. 5x is the greatest common factor. All right. What is the complete factorization? Nice. All right. Well, looking at these 3 terms here, let's focus first on the coefficients of 8, -4, and 10. What do all 3 of those numbers have in common? What's their greatest common factor, you could say? It's like, well, 2 for sure. They all are divisible by 2. Okay, how about letters? Well, we got a y cubed, a y squared, and a y, so they all have one y in them. Got to default to the smallest amount. So what I just did is found the greatest common factor. Now that I found it, I'm going to factor that out. So what's left over if I divide 2y out of each of these terms one by one? So if I divide 2y out of 8y cubed, 8 divided by 2 is 4. Y cubed divided by y is y squared. It's like I took a y away, and now there's only 2 left. Okay, and then I go to the next one. Okay, if I take 2y, if I divide that out of -4y squared, I get -2y. If I remultiplied 2y into whatever I'm claiming the leftover factor is, it should get me back to the original value, and it does in this case. Divide 10y by 2y, and we get just +5. So that means my answer is J. Nice. What is the correct factorization of that? Oh, yeah, awesome. So the factorization or the factors of a trinomial, quadratic trinomial that has an x squared term, an x term, and a constant term can be found by using the target product target sum table. And this should ring a bell. Your target product is going to be A times C. Your target sum is B. So in this instance, my A value right here is actually 1. I don't know if you remember this from this unit, but when A is 1, we can skip the box method and just take the results we get from doing this and write our final answers. So B is 13, awesome. A times C is 30. So we're looking for two numbers that multiply to 30 and add up to 13. I thought I had them with 2 and 15, but you have to subtract one of them, and we don't want any negatives in this case. How about 3 and 10? Ah, yes, 3 and 10 are going to work. So because a is 1, we can jump straight to x plus 3 and x plus 10 being our two factors. The 3 and the 10 written with x's. They're both positive. That fits. If you're doubting your answer, you can use the box method or FOIL first, inside, outside, last, or outside, inside, last, and you should get the original equation. All right. So in real time, target product, target sum, a times c is 18, noting that a is 1 here, so this is the fast one. All right, negative 11. We're going to split this up into, 2 and 9. 2 times 9 is 18. And if we make them both negative, they still multiply to positive 18, but they'll add up to negative 11. So H. Negative 2, negative 9. Okay, so finally we have our first example that has an a value that's greater than 1. So this is going to be the longer scenario. We're going to start the same way. Target product, target sum. A times C, 3 times 8 is 24. And target sum is 14. Cool. So we're going to split this up into, 2 and 12. Hey, 2 and 12. 2 plus 12 is 14. Great. Awesome. Fantastic. So now what I'm going to do, and I'll switch to purple here, is I'm going to draw my box. Okay. I'm going to put the a term, 3x squared, in the upper left box. That's right here in purple. I'm going to put the c term, which is positive 8, in that box down there. And the two numbers that I found, 2 and 12, from the first step, I'm going to put in the other boxes. I'm going to put x's behind them because, remember, what we're doing here is we're splitting up 14x into two numbers, 12 and 2. They add up to 14, right? But by splitting them up in this strategic way, we're able to now find the GCF of each row, okay, and column of this box, the greatest common factor of each row and column of the box, and get our two factors, which I've written in green. Now, another way of doing this, once you do the first GCF, is you can say, okay, well, here's my purple 3x squared. All right, I figured out that x was the GCF of this row here, so I had to do that one time to get the process going. But then, let's say I don't know what this is. The question I'm asking is, how do I get 3x squared by multiplying x by something? What times x is 3x squared? And most students are comfortable saying, oh, 3x times x is 3x squared. So you can unravel it like that. Yep, those green factors seem to be option B. Cool. Okay, so one more time in real speed. We got target product, target sum. A times C is going to be negative 10. Ooh. And B is going to be 3. Fascinating. So we've got 2 and 5, but we've got to get negative 10 when we multiply them. So one of those two numbers is going to have to be negative. I'm thinking the 2 should be negative because we want to make sure they add up to 3, positive 3. So the 5's got to be positive. Negative 2 has to be the negative number. So that's great. Awesome. We've discovered our numbers that go in the upper right. I'll put the negative 2x there. And the lower left, I'll put the 5x there of our box. Woohoo! All right. Doesn't matter which of those two boxes. You could switch those two blue numbers around. You'll get the same answer. So we got 2x squared. We got negative 5. Life is good. Okay. So now we're doing some GCF work here. So in the first row, top row, 2x squared and negative 2x, what goes into both of those nicely. Well, a 2 does for sure, and so does an x. Okay. And now I can fill in, what do I multiply 2x by to get 2x squared? Well, just another x. Over here, I need a -1 to get -2x. Down here, I need a 5. And then that multiplies to get -5 just fine. So I am set. F seems to match those two green factors. Difference of squares was a vocab term that we talked about back in this unit, and it referred to scenarios in which we had an x squared and a constant, okay? And the coefficients were perfect squares. So that's the squares piece of this term, difference of squares, okay? So those are perfect squares. Also in J, we have perfect squares. 1, even though it's not written there, is a perfect square, and 25 is. Here we don't have perfect squares on any of those numbers, so that's that. And then the word difference. So difference of squares means we're subtracting. The word difference means subtraction in math. So there's a minus sign. That's got a plus sign. H is the answer we are looking for. Now, if you're curious, if we wanted to factor that, we just take the square root of the first coefficients. The square root of 4 is 2. So 2x and 2x. 2x and 2x is 4x squared. And then we take the square root of 1, which is 1. So we're going to have 1 plus and 1 minus. Those are my two factors of 4x squared minus 1. So look at this. We got 25 and 36. Those are both perfect squares. And we have subtraction. We got an x squared and a constant. We got everything we need right here. The square root of 25 is 5. Okay, so 5x squared. Maybe not x squared, maybe just 5x. There we go. Okay, 5x. And the square root of 36 is 6. So we're going to have a plus 6 and a minus 6. So it looks like letter C is the answer we were looking for. That seems like a really nice, natural place to stop for this video. Hopefully you found this helpful. Thanks for watching. We'll catch you next time. Bye.